Hello, welcome to another coding session. Last time we got further with bulls. I think that's enough with bulls for now. I think we've got this side to a point where we can do some useful stuff. I do think something that there's a bit more to bulls that we haven't done, you know? We could have like bool A and bool B, you know, we can have ands and ors and nots, that kind of stuff, which would be nice, but let's just leave that for now. I kind of want to move on to this side of the assert now, see if we can get strings going. I'm a little bit scared of strings, but I think at the moment it shouldn't be too bad because we're just going to do super basic string handling. So there's not going to be any manipulations of strings at all. I mean, I guess to start with, I just want to be able to go like something like this, you know, something very basic. So we can declare a string, and then I want to be able to print the string like that. So I think this here is going to be challenging enough. So let's see how we go. I kind of want to start actually, because I think there's a bit to it, I kind of want to start just with this and see if we can get that creating the proper assembly. Obviously we can't really test the output because there is no output, but let's see if we can just start with this, hey? So if we go into our grammar, we will want to add I guess as part of our primary, we will want to add the ability to have a string literal. So over here in all of our options, let's add a string, and string is, put that here. So what is a string? It's like the double quote character, let's take this away, followed by something, followed by another double quote character. And I guess this thing is just like also a double quote character, but it's like not. Like a double quote character, and then so we'll put a plus here. So 0 or, I guess it's star. So it's like 0 or more non-double quote characters. Just kind of making this up as I go, this syntax stuff. But yeah, so it's like not this. And this looks weird because it's like 3. Oh, I've got 4 over here. 3's bad enough. Let's just keep it to that. So literally a double quote followed by 0 or more characters which are literally not double quote followed by a double quote. That is a string literal. So I guess that includes new line, which is not usual. But like I said, we just started real simple. Real simple like. And our data types, we have a new data type. So let's go like that. String. So now we have string. So I think that's enough extra stuff in our grammar to handle this. The string data type, which of course we need to make pretty. Where is it? Color scheme. File types. Bangalang. string. There we go. So string is pretty. Yeah, so I think we have all the grammar there. So first thing is to add that grammar to the tokenizer. So we're going to need a string token type and also a string data type. And then we're going to need to be able to parse that string. I do think I might put this right at the bottom actually. I do think that I would like to refactor this. We might have to have like a bit of a cleanup session because I think this tokenizer is getting a bit out of hand because I'm just like copying and pasting a whole bunch of stuff all the time. But let's see. So if we find a double quote, what are we going to do? We're going to keep going as long as we don't find another double quote, right? And then in the end, we're going to say, hey, there's a string. I guess we're going to do start index +1, end index -1 for the value because we don't want to include the double quotes in the value. Is that a tokenization thing or is that a parsing thing? Maybe that's a parsing thing. I feel like the tokenizer is like should be as stupid as possible. Yeah. Okay. So I think that's enough. Actually, that was pretty quick. So we added this thing that's super simple and probably has some sort of issues when we get into complex cases that I'm not going to handle right now. And we have this, yeah, the string data type, which is here. So let's go to parsing. So when we parse a primary, let's see, what did we change in our grammar? Yeah, so in our grammar now there is a string type that it could be. So it is primary. And I'll put it here. So same ordering as our enum string. So I think we need to add also a string type to here. Let's put that there. So is this where we want to strip it off? No, let's even leave it for now. I think that's it, right, for this. We just handle that node. We also need to handle the string data type. But I don't think that's like any change to parsing. I think that's more type checking. So let's move to the next step of the pipeline where we check our types. And primary is the right place. So if we come across a string, so this is a string literal node, then I guess we give it the type of string. That sounds pretty good. So far, so good. Generation. So we're in primary again. I think this is where things are going to get more interesting. Yeah. So the reason we're more interesting here is because the string data type, let's copy a couple of boxes. Maybe I'll give this its own spot. So this is a string. and it consists of a length, which I'm just going to make an I64 for now, and a pointer to the actual data. So that's what it is. It's kind of like there's also like in Odin there's slices, which I guess is the more general case of this, where the pointer is not to string data, but it could be to all sorts of different kind of data depending on the type of the slice. But we don't want to go general straight away. We're just going to do this specific use case of a string, and then later we might generalize it to a slice. But anyway, the concept of a string is that it holds a length and a pointer to some data. So we know that the data being pointed to must contain this, must be this long. And for now, because all of our strings are going to be just like literals like this, they'll be stored directly in the executable, and our assembly will refer to that. This is something I already did in Bangalang, in the other language that I made. And I double checked that and saw how to do it again. So maybe we'll actually handle this part first. Well, I guess that is what we're handling, but I want to start from the beginning. So this is our generate program, and these are the lines that we put at the very start of the program. So now I want to change it so that we go section.text. We haven't used sections yet, but in assembly, or at least in NASM, you can declare sections, and the .text section is where all the instructions go. So all the stuff that we've made so far has been instructions, so it all goes in text. And I guess if you don't specify any sections, that must be the default because it's been working. But then down below all of our instructions, I'm going to make a section called data. And this is where we're going to store all of our string literals, which we can then refer to with our pointers. Okay? And just to be super simple, I don't like this naming actually. I'm going to rename this. It's like an address size, not a memory size. So this is saying that addresses we're using 64-bit addresses, right? We're on a 64. That's when people say a 32-bit processor versus a 64-bit processor or operating system or whatever it is. That's what they mean. The address, how big the addresses are. A bigger address means you can have more addresses. Anyway, that was a weird aside. So I'm just going to call this data section strings. And that is a dynamic array of strings. So this is just a global that I'm throwing in here just to make things easy. And here, so we're going to populate that as we go through the program. And then right at the end, we're actually going to put them into the executable so they can be referred to. So maybe it, no, I think this is fine. So for data section string in data section strings, and I think we need the index also, we're going to print a formatted line that, can I remember how to do this? I think it's db for, well, first we need to put the name. So the name is going to be string underscore I. This is why we needed the index. So string I. So it's going to be, it's kind of like a label, right, for the variable. And then this db is define byte. and then we're going to have our string surrounded by double quotes. So that's how we define strings in the data section. So now we have that established, we can go back down to here, and when we come across a string, we need somewhere to put that, right? Like everything so far, or a lot of things so far, has been just, we're like using registers and stuff. But I guess for arrays we are not, and arrays are getting directly returned. But I think for strings, I think the way, maybe we'll change this later, but the way that comes to mind that we're going to need to do this is we're going to need to allocate some space for it. Now this is something we already do in generate call, right? In generate call, we allocate space for the return value and for the parameters, and sometimes we keep them on the stack until the very end of the expression, where is the end of the expression? It's here, until the very end where we clean it up. What is this? What is this? I think one of the reasons I'm looking forward to this test suite is because I'm sure there is like so much crap like this in here. Is that right? Yeah, that was totally wrong. But this is where we clean up the stack. So I'm going to allocate some space to put this string object in. And then we will refer to that within the expression. And at the end of the expression, it should get, if we want to use it outside the expression, which we should want to, it'll get copied out to somewhere else. And then this will get cleaned up by what we just fixed before. So how big is it? Well, I guess we need to have a data size for string, and it's 16 bytes because we have an 8-byte length and also an 8-byte pointer. So string is 16 bytes. So here's the size. So we need to allocate that size with the context. So now we have space for a string on the top of the stack, and we need to populate that. So the first thing we want to put in is the length, right? That's the thing we said goes first. So we put that at RSP0. Oh, so that's the destinations, and the size is 8, I guess. So the source is, I guess it's an immediate. And that immediate is the... so our string is still surrounded in quotes, right? So I guess we could just say length. Well, I guess we could just say length minus 2, right? Maybe we'll just do that. So it's like the node, the length of the node's value minus 2. And maybe we actually never strip the quotes off, and we just go like that. I don't think there is actually a reason to take them off. Let's see. This is not working. Oh yeah, I think I have found a way around this. So let's give it a go, because I wanted to have an immediate like a variation where you just pass in an int. But last time I tried it, it failed. So let's go like this. And so this one I want to pass in an int. And I think what I do is have a buffer of like 8 bytes seems to be what I use. And then str_conv int to ASCII, and we pass in a slice of the buffer and the value. And this was giving us garbage, but I had to play, and I think it's just that I need to clone this bad boy. I think it's probably because we're using this buffer, and then the buffer, you know, it's on the stack and it just gets cleaned up, and then that memory gets reused, and then our string turns to trash. But by cloning it, we get around that problem, seems like. Oops. So where do we... Yeah, so now if assuming this works, I should be able to fix this kind of stuff. This here was 100. Okay. So we've copied the length in, and then the next thing is we need to copy in the pointer. Now, in the case of this assembly where we have, no, where did I do it? Up the top here. Yeah, we have this kind of thing. This label, this is also kind of like the name of the variable. So, and you can use it like a pointer to the variable. So that's exactly what we need. Where were we? Here. So this time we're offsetting by 8. And I guess technically the size is address size. And what we're putting in, I'm going to say it's also an immediate, because we just want to like put that name straight in, and that's kind of what immediate does. I mean, I guess we could make a new type called data that does exactly the same thing, but for now I just call it immediate. So we're going to need to do something kind of like what we just did here. I'm going to need to just copy that whole thing. We're going to need to copy this string, which is, yeah, it's the node.value. No, it's not node.value. It's the data section strings, the length of data section strings. So that gives us the index, right? The index is what we want in here. The index of the string, because we will we'll actually add it in here. So we add it after, which means that at this point, like if this is the first time we come in here, at this point this is still length 0. There's nothing in it, so we get index 0, which is what we want. And then we basically want to concatenate like that. I'm going to call that string name, and that's what we want to put in there, I think. So I think that is, I think that's creating us thing, but then we don't want this. I guess kind of like we do here, we want to take a copy of so we nominate a register, we copy from the register RSP. That's what this is saying. It gets a bit confusing sometimes, but the SP with size 8 is RSP. So it's copying from RSP, the stack pointer, to this new thing. So we have a copy of the top of the stack at this moment in time. And then we give that back as a memory location. Might want to extract this kind of thing at some point. What's wrong? Oh, nothing. Just slow. So I think that's all good, maybe, for the primary. And this side should allocate enough space for it. And then once all the expression stuff is done, those 16 bytes should get copied to here. Let's see what happens. Oh my. Huh. Okay. So it's treating this as the first character of a token. So my tokenization has got some errors in it. Oh yeah, because we don't include the closing double quote. I guess we can say, if, because this check is making sure we haven't gone past the end of the file. But if we have gone past the end of the file, then we've got some errors here. Then we can say like unclosed string. And then the next thing we can do is put another increment on here to get past the double quote. Because if this has happened and if this hasn't happened and we haven't crashed out, that means that we ended because we found the closing quote. So we just skip past it. Boom. Process finished with 64, which I believe is the correct value for this return. But what I'm interested in is the assembly for this. So first off, we have section text. If I scroll to the bottom, this is our new data section. So yeah, section.data, it has a string 0, which defines the bytes my string. That looks good. And then we need to skip up to, I believe it's here. This looks like string 0, okay. This is some Boolean stuff, so I think it's this declare is what we're interested in. Yeah. And the next thing should be an array declaration, which is this. So this is the assembly we got. This first allocating 16 bytes, first off, that's a good amount. Now, so that'll be for the left-hand side, the allocation. This here should be the, that's when let's skip, that's this here. So we do our allocation and 2 copies, allocate, copy, copy, and then we do also a third copy. So this is the allocate, copy, copy. So this is the temporary spot for our string, and then putting the length, which in this case is 9, and then the address of the string into it. Then copying the current top of the stack to R8. Well, this looks a bit funny, doesn't it? And so does this. Why are we allocating? We're not allocating. We are just doing a bad job of putting comments. Deallocate, deallocate. Okay, so that part looks better. So I guess that's like at the end. Remember, this is like a temporary thing. So at the end, we clean that up. But this is a copy from R8 to RSP, but they are both the same. So that is pointless. So this copy is this one. We just want to keep a reference to the current top of the stack. So I think that's right. But then this copy, which is the only other copy, and I believe it's up here in generate expression. This copy here is where we copy it to the left-hand side. So we're trying to copy it into this memory that we allocated for the left-hand side, which we seem to think is at the top of the stack, probably because in it's a declaration, right? Yeah, in here we are saying like we want it to be on top of the stack because that's what we just allocated. So that's right. And that's right. I think what we need to do is move this. I think this wants to go up here. So we saved the location where we've temporarily put our thing. So now we can clean up the stack. And now RSP is pointing to this, our left-hand side allocation. I think I could do a better job of like annotating all this stuff to make this clearer, but that's my understanding. So I think we need this to be here, which would mean swapping those around. Is that going to break anything else? No, I think that's only good. I think that's only good because, yeah, a lot of the time for declarations or even other things, if we wanted to put it somewhere on the stack, if that's our destination, we need the stack to be correct, right? We almost want to use like the outer stack, not the inner stack to I mean, let's just get in the byte size. Okay. Yeah, I think that's it. So then, yeah, like I mainly moved this up there now before, but now when I did a build, it's still there. So I think that's the correct assembly for this declaration. Now we want to try and do a print. Ooh. So I think for now, because print is a syscall, we're going to do another built-in procedure like exit. So we have print, 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 and it will take in a string. Easy peasy. And in generation, I did just realize that we probably want to do some more type checking now that we have a string type, because we assume all of our types to be numbers up till now. So we'll just keep that in the back of my head. But now let's continue with where we were. So now we've kind of, in type checking, we've kind of declared this procedure. So now let's actually implement it. Print, and let's go check out, I think I have it already open. Here we go. This page here is the Linux system calls. If you're on a different platform, system calls will work differently. but what we want is write. So the way it works, at least in Linux, is that everything is kind of treated like a file. So you pass 1 to the first parameter, rax, like this, and that means we're doing a print. And then to RDI, the second parameter, you pass a file descriptor. So that's like, which file are you writing to? And one, again, is reserved for standard out. So printing to the console is treated like a file. It's treated like writing to a file. Maybe technically it is. I have no idea. So that we need to put that there. And we need to put some more parameters. So we need to point it to the data and the count, which sounds very familiar, doesn't it? That sounds a lot like what our string structure is. So which registers do we need? RSI and RDX. RSI, RDX. And because of our calling convention, we know where they are relative to the stack pointer. So the top of the stack will be the instruction pointer that always gets pushed on when you do a procedure call. So that's going to be 8 bytes. Then we're going to have the string object, which starts with the length. So the length, I should say like 1, 2, this is the buffer and this is the count. So the length is here. So that's going to be plus 8 to get past the instruction pointer, and that's going to be plus 16 because it's going to be what's stored past the instruction pointer and also past the length in the string object. The next thing is the pointer. So I think, is that it? Holy shit. Okay, I printed out my string. That's really cool. And unexpected. I didn't think we would get so far so quickly. I mean, could we even declare an assert procedure, which is like assertion, which is a bool, and message, and then in here we'd say like if assertion equals false. Normally you would just do not assertion, right? But we haven't added that feature yet. So what to do? I'm just going to return a bool because I think in our language you kind of have to return something. I should do something about that as well. I think if this is omitted, then it will not parse. Invalid token, line 122, column 9. Oh, that's Odin syntax. Yeah, see, expected an arrow, but it got the opening squiggly bracket. So it wants that. Now it's happy. So I think if I omitted this, it would not complain. Yeah, let's just return true anyway. So we can probably just go print assertion failed, print message, and exit with code 1. It's happy with that. So let's change that to, well, we have this assertion already, right? So this assertion should trigger now. Assertion failed, true is not false. my prints do not have new lines, and I bet that's not going to work. Nope. Interesting. Interesting. How can we do that? I mean, maybe it's a little bit advanced to start adding this kind of capability. Because yeah, I don't really want to do any advanced string handling, and I'm going to call this advanced. I mean, I'm pretty stoked that, you know, and I finished with Xcode 1. I'm pretty happy that just, you know, we have an assertion now. And if I put not equals, we get the 64 Xcode because it goes to here. I'm just going to do that for now, so it looks like it was intentional. But we can't do new lines yet. But I'm totally happy with that. That's like pretty awesome. We're 40 minutes in. There is something that I think is an issue that I found, and I think we have time to have a go at it. I think it's quite a big issue. Hopefully we can manage it. So let's have a try. Before we get too carried away putting assertions around the place. And this is it here. I found this. On a side note, I misspelled this, and I want to maybe just correct the spelling. So in type checking, this is not how we do type checking. This is not, we should be going like this. If not coerce okay. Oh. Okay equals false. But it's if not expression 1, okay. Is that going to create any more errors? No, it doesn't. Okay, I thought that was going to create a bunch of errors. I guess the errors still would have been vocalized, but it wouldn't have caused the program to stop. You know, it would have just gone ahead with the generation anyway. So that's something I wanted to fix. There's a couple other things I'm aware of. And I think the one I want to have a go at is this tokenizer. Like I mentioned before, the tokenizer is a mess. So let's make it less messy, shall we? And I think I want to do that by making another stream, which is a rune stream. Like so. It's going to have peak rune, next rune, like so. So where is our kind of conditions? So I get a, yeah, like this kind of thing, right? Stream dot not index is greater or equal to the length of stream dot source. That means we've gotten to the end. And I think it's just like a 0 to return a rune. Or can it be like, is there like a nil rune? Maybe seems happy. Oh no, it doesn't seem happy. It's just slow. Otherwise, we're going to return stream.source next index. Yeah, that sounds like a peak, which is a, yeah, string handling. I don't get string handling. That's why I'm scared to try and implement it. We need to cast it to a rune because the string is actually like an array of U8s, unsigned 8-bit integers. Don't ask me what's going on. So then how do we do like next token? Next token any, it does a peak and then it increments and then it gives it out. So let's do the same thing. So this time we peak in a rune. This is our next rune. Like that. Okay. So now we have like a rune. And the main reason actually that I wanted to do this is because I actually, yeah, that's right. I also want to maintain this information in the stream. So I don't have all this manual business. Someone put a comment on one of my videos where I implemented some of this, I think. And he's totally right. Like, I think this should be, I think this should be kind of encapsulated a bit, so I don't have to manually do it all the time. So where is the logic for that? I think it's kind of like this. So when we go next rune, it's like, if the next rune is a new line, then we increment the line number, reset the column number. Otherwise, we implement the column number. All right. Okay. So I think that's the basics of a rune stream. We might need to add some stuff to that. Rune stream. I guess it's like source. What else do we have in here? Next index, where we start at index 0, and the line and column numbers should start at 1, right? Are you happy with that? No? There. So we don't need to keep track of this anymore. And we say for peak rune does not equal 0. Oh, I guess we need the address of the stream. All right. So now it's kind of like if we've come across a space, you know, all this logic is taken care of, and also this is taken care of. So it's just like we just need to do next rune to skip over it. And now with these kind of ones, there's so many of these. What I want to actually do is make a fixed token, just fixed tokens, I guess. Which just maps a certain token to a token type. So I guess we could sort of like take all of these tokens, bring them down here, and we can say fixed tokens something equals this. Sorry, I know this is very manual. There we go. So, opening bracket, closing bracket, opening angle bracket, opening angle bracket equals, closing angle bracket equals, opening square bracket, closing, opening squiggly, closing squiggly, colon, equals, exclamation equals, plus, minus, asterisk, backslash, comma, hat. Arrow is like that. Oh, keyword. Okay, these ones do not go in there. It's just these ones where they have like, it's just a fixed pattern for this token. So then instead of like all of these cases, where I'm just repeating the same pattern over and over and over again, all the way down to here, I guess. I kind of want to do this. But I want a string like of 2 characters. I think I want something like, I was thinking I might need something like this to be able to peek 2 runes at a time. So then we can say like, if we find a 2-character one, or if we find a single character one, then we can just create the appropriate token. So we'll go back up here and maybe do like a peek runes with a count, and it goes back a string. Plus count is greater. And in that case, we'll just return an empty string, I guess. And here, I guess it's just like a subset, right? It's like this, and then index plus count is the end. I think that's right. So if it extends past the end of the input, we're just going to return empty to say like, you know, this went too far. So kind of like we can compare it back against 0 in the loop below to say like, hey, we went past the end of the file when we tried to get a single rune. When we get multiple runes, we check against an empty string. That's the idea. So that gets back a string. So let's just peek runes, next runes, and we plus equal count. And I guess here we need to like loop through them to know what to do. Next rune of in next runes. So each of those we perform the appropriate updates. Yeah, I think that's it. So yeah, now we have this. This is the kind of thing we want to do, is create a token. So that type is so I guess this is the value. So this is going to give us the, I guess it's the fixed token types, because this is giving us the token type. And from the stream, we can get the line and column number. And then we actually need to, the reason I didn't do next here, I did peak, is because I wanted to maintain those numbers. So now we'll do next to consume them. And this is the same thing, except we're only dealing with one. And we do this first. So we look for any 2 character tokens. And if we do find one, then we create the appropriate token. And then we look for single character tokens and create that if we need, because yeah, some of them are single and some are double. And like this, for example, if we looked for the single character tokens first, we would come across this before checking whether that existed. Like maybe it's actually that. So that's why we do the 2 character one first. This is already looking much nicer, I think. That's all the comment handling. Oh, this is more single character stuff. So the comment handling I kind of want to come back to, I think. And string handling, let's just do, I think these ones at the bottom are going to be not so bad. So this is like peak rune. And how do we want to do this? I guess the start. So does this index variable exist? Because if it does, we don't actually need it. I feel like it does not exist. It just doesn't realize it yet. So start index is equal actually stream dot next index. And then I'm going to consume that first rune, right? And then while peak rune does not equal 0, and peak rune is somewhere in there, we're going to consume the rune. Right? And then the value is going to be like from start index to the current next index. Oh, but then our line and column numbers are going to be wrong. We don't need this. Yeah, the line and column numbers are going to be wrong unless we... actually, like, instead of just the index, maybe we save the whole stream there. So it's like initial stream dot. So this creates a copy of the stream. Well, I guess we need to dereference, right? We want to actually copy the stream object. So this is what the stream looked like at the beginning. So its next index should be the first index. And also it should have the correct column and line. Why is that not happy? Oh, no, I don't think we do need to dereference because it's already just, yeah, it's not a pointer. Okay. Yeah, I think that should do the trick. And then we need to do something similar here. So we need to switch to peak rune. And do this to consume that first character and save the state. And well, peak rune is not 0. It's probably not actually necessary to check for 0 in these cases because we're already checking that it's within a certain set, right? It has to be one of these things that we're saying. So we probably don't need to do this. Yeah, we're saying it's got to satisfy one of these things, right? So, and same here, we're saying it's between 0 and 9, so we know it's not 0. Yeah, because this 0 is actually the ASCII 0, it's not 0, 0, the integer 0. So yeah, I think that looks nice. So now I guess we want the current stream end index to be the end, and then we determine the proper type. This doesn't need to be there. Cool. Okay, I think that's those done. Let's do the string. So we need our peak rune again. If we peak and we find a double quote, I guess maybe we do the same sort of pattern. And here we do need to say like it's not equal 0 because we're just saying that it's not a double quote. So it's not a double quote and it's not 0, so we haven't got to the end yet. Then we say next rune. Oh, that needs to be next rune also. And then if it is 0, we did get to the end. That's an unclosed string. Like so. So we need to consume this guy. So we're consuming the double quote at the end. Initial stream next index, stream next index. Okay, so I think that's the string. And so this here, I think we can split out, you know, because we can check 2 characters at a time now. See, like this. So I can say if that's // that's this case here. Right, and then we can go boom, 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 boom. Yeah, and this here is like saying, this is trying to do just the / token, but we've already taken care of that with our map that we made. Actually, that makes me think that these need to go below the comments because above the string literal, yeah, we put it above the string literal. But they need to go below the comments because otherwise that / is a divide also. And so as soon as it sees that in the map, it's going to be like, oh, this is a divide, and not do all the comment stuff. But we want to do the comment stuff. And this should be now /*. That's nice and that's clearer, isn't it? I like that. So we can just do.
What do you want to turn on?
Oh, Jesus. Stupid Alexa. Okay, so we consume the 2 slashes, and then as long as we don't find a new line, we just want to keep going, right? So as long as peak rune does not equal new line, we're going to say next rune. Just keep skipping past runes until we get to a new line. I think that's it. Slash star. So again, let's just consume those. And while we have more, so that's while peak rune does not equal 0. Then again, we're looking for, this is the slash star pattern. If we find another slash star, we consume it and we increment the nested count. Nice. And if we find a star slash, so that's the end of a multi-line comment, we also consume it. And if we did have a nested multi-line comment, then we decrement that count. Otherwise, we break out of this. So we're saying, basically we're saying that we're done. Yep, that sounds right. If we find a new line, so I think the reason that we did this is because we needed to handle the new line case properly, but now our stream does it automatically. So basically we just need to like, if we didn't find one of those patterns, then it's just a regular old rune that we want to skip past. There seems to be an error up here. Oh, we need to pass count in. And an error down here. Because we need to do string dot. So what happens with that? Unclosed string at line 113. So it thinks that that string is unclosed. This string is happy about. This string is a no-go. Okay, so let's have a look at the 34. It seems to think that's a new string. So I think we might have reintroduced that issue with strings. Maybe we had this in the beginning. Although it's interesting that it's done it on the second string, not on the first string. The second string, yeah, probably chains until it gets to the last one. But we do go next rune. So that should consume. This is already. No. I think we need to peak here. Yeah, I think we were getting a bit overzealous with our next runing. Yeah, there we go. So that seems to have all worked. We are already at 1 hour and 10. But another thing that was commented on one of my videos that I want to have a go at, hopefully it doesn't take too long, is to do with multi-line comments. And it was like, what if we go like that? Yeah. Or what if we go like that? Like if I copy that and put that in there. They currently are going to end the multi-line comment and we're going to get some sort of error, right? Invalid token start, line 74. Yeah. So I think this is ending the multi-line comment. This is valid code actually. But then this is not. So I want to handle these cases. And I think the way that I want to do it is I want to sort of extract out this code that will parse a string. So I kind of want to read string or something. I'll call it read string. So we need to pass in a stream, which is a pointer to a rune stream. And I want to return the length. I think that's going to be important. So we don't need to put our ampersands because we already have a pointer. Doodaloo. So that should parse out a string. Let's make that a named return so I can just go length plus equals 1 whenever we do next rune. Like so. So that'll read a string and give us the length of it. Where's our string? I think it's here. So here we just call read string. And we need to pass in a pointer to a stream. And that does all that work. So here I'm going to say minus length to get us back to the start of the string. So actually, do we need this copy? What do we? I guess we use it for this information. Yeah, we'll keep it. Why not? And we also use it for that information. So we'll keep, oh wait, I'm looking at the wrong place. So do we need to keep it here actually for that information? Yeah, I guess we do. So we can do like this. So we can just do that. So I think in this case, we don't actually need to use that length, but we will use it. Or will we? Actually, no, I don't think it's needed. I'm just going to read a string. Okay. Now the reason I wanted to do that was because then when we are in here, for example, we're looking at a multi-line comment. We've checked this pattern, we checked this pattern. Then we want to check another pattern. Else if peak rune. So if we find a double quote, then I want to read a string. Yeah. So and because the read string is going to take over. Sorry, I sort of jumped around a whole bunch there. Because read string is taking over, read string does not give a shit about this stuff. So it's not going to stop when it sees that. It's just going to read a string. Boom. Okay? And likewise, this is read single line comment. Which takes in a stream. So these procedures, they assume that you are at the start of a string or at the start of a single line comment. Yeah. So then, sorry, I'm doing a bad job of remembering where I was or finding where I was. So this should be read single line comment. And then we'll have another guy in here that says, hey, if you find a comment, read single line comment. So now it's going to be like doing the nested stuff, nested stuff, nested stuff. Oh, I found this. So now I do a single line comment, which should take care of all that. Then it's going to revert back to nested stuff, nested stuff, nested stuff. Oh, I found a string. So it'll do the string stuff and then revert back to, so that's going to allow us to just ignore these. Fingers crossed. Hey, yeah, because I can take that out now. And it worked. So we have more robust multi-line comments. We have a nice tokenizer. We have strings. We have asserts. Booyah. That's pretty sweet, if you ask me. I'm just going to go string or stra. I think you can just do that, right? That's valid. Just be really explicit about what we're doing here. Yeah. Cool. Yeah. Happy. All right. I think that's a successful session. Yeah. Yeah, super. I was not expecting to get that much done. I do know that there's still issues. Issues are definitely still present that I've found while playing around. But I think we took care of a lot today, and I'm super happy with that. So thanks for stopping by. Have a good one. Ciao for now.